Okay, class, we're going to start chapter 15. We're going to start covering interfaces and generics in this PowerPoint presentation. I just want to kind of do another one of my overview videos again that will talk about what interfaces are, why we use them, and how to implement them. Then I'll do a demonstration afterwards. So getting started here with the objectives, being able to develop interfaces for your application, develop your own interfaces, and then distinguish between an interface and an abstract class. This is a pretty big interview question. If you're looking for a job in the market of software developing, I want to say if you're maybe looking for a co-op or something like that, it might not be as popular. But really being able to talk to things like this and distinguish between an interface and an abstract class, really in depth, if you can speak to that, shows or really starts to distinguish the good developers from the bad developers, I guess, or not the bad developers, but just the ones that might not have as much knowledge about the subject. So we'll talk about this a little bit. Here's code to show an interface, and we'll talk about what an interface does and why we use it here in a minute, but this typically goes in a new file. As you can see, we have interface. Typically we put public in front of it, and this interface's name is iDisplayable, so it's much like a class. Excuse me. So it looks pretty similar to a class in a class file. And here's a product class that implements the iDisplayable interface. So if you've taken Java 2, we've talked about interfaces. What an interface is a contract between the interface itself and the class that's implementing it. So, for example, what we're going to be doing here is refactoring our code to use this iDisplayable interface, and that should override this getDisplayText, and not override as inheritance does, but we're going to be refactoring it to use this interface rather than having our own implementation. And then as we go through the lecture and as we go through the demonstration, we can see why having it as an interface, how that helps as far as polymorphism is concerned. So when we talk about interfaces and inheritance, that really brings up the third object-oriented principle, which is polymorphism, which means you have the ability to choose which implementation you want when you get to it. So kind of like we used product and then we chose between a gaming system or a book. So we kind of just threw that in our list of products. But then when we needed to display a form, we said, okay, we know it's a product, but is it a gaming system or a book? So we can use polymorphism to make coding easier, more efficient, use less code, and also exhibit standards in our code. So here's some code that uses the iDisplayable interface. So you notice you can use it as a type here. So much like we use IEnumerable, here they're using iDisplayable product equals new product, and because that this implements the iDisplayable interface, we can do this syntax. Here's this slide that covers the comparison between interfaces and abstract classes that I was speaking of earlier in the PowerPoint presentation. So as you can see, the first bullet, both interfaces and abstract classes provide signatures for properties and methods that a class must implement. So if you remember, back in a previous video when I was talking about inheritance, I was going up the structure of the components on a Windows form. And if you remember, I kept F12ing over everything that a class was inheriting from, and I kept F12ing and F12ing all the way up the inheritance chain until I got to an abstract class. I don't remember what the abstract class was called though. But if you look through that class, you can see that it might have some things in it that resemble how we might describe an interface. So an interface and an abstract class provide signatures for the properties and methods that a class must implement. So where we start talking about a difference though is all of the members of an interface are abstract, which we'll see when I start coding one here in the demonstration. But in contrast, an abstract class can implement some of its members or all of them. So as long as one of the methods in a class is abstract, then the entire class is abstract. A class can only inherit one class, so it's C#, much like Java, single inheritance. You can only inherit from one class. But a class can implement more than one interface. So if you'd like, you can implement iDisplayable, iEnumerable, iDisposable, any kind of interface you can implement on a C# class. And notice interfaces are always prefixed with I, so that makes it easier to distinguish it whether it's an interface or a class. Here are some commonly used .NET interfaces. iClonable, so notice it's prefixed with I, and then the type of functionality you're gaining by implementing that interface. So if it's iClonable, then that object or class that you're implementing it on has the ability to be cloned. So maybe you're trying to set an object equal to another object and save its state off. iComparable, so maybe you want your class to be able to be compared to other classes or maybe itself. I already mentioned iDisposable, and that just makes garbage collection a little bit more efficient. So if you have a lot of objects in your application that you might want to dispose of quickly to free up memory, you can implement iDisposable. Here are common .NET interfaces for collections. I mention iEnumerable a lot. iEnumerable allows us to do all the cool things we can do with LINQ, like when I do a .forEach or a .where or a .select. So whenever you do any cool stuff like that, it has to implement this iEnumerable interface. And if you notice, the members of iEnumerable is another interface of iEnumerator seen below, and it allows you to enumerate through a collection. So you notice here get enumerator, and then it allows you to get the current object, move to the next object, reset, etc. Some other interfaces, iCollection, iList. iList is another big one because it's what list implements, and it allows you to add objects to a list, clear a list, remove at a particular index. And an iDictionary, which is similar to iList, as it is implemented on a dictionary to allow you to do these things here below. The syntax for creating an interface, so we have public interface, just like we have public class, and the interface name usually prefixed by I. Interfaces can have properties, as you can see here, or methods. But you notice that the method looks a little bit different because it doesn't provide an implementation. So you have the return type, the method name, and the parameters, and then a semicolon. Because when you get to the object is when you're going to provide an implementation. So for example, an interface that defines one method, we have public interface iDisplayable. And then from iDisplayable, we implement one method called getDisplayText with a semicolon, because we're not going to provide an implementation until we implement it on our class. Interfaces can also inherit from other interfaces, which we won't be doing too much in this class. It's not very common for interfaces to inherit from interfaces. The syntax for implementing an interface is much like the syntax for inheriting from a class. You use the colon. And then if you're inheriting from multiple interface, you simply use a comma. So for example, product, we want it to implement iClonable and iDisplayable. We just simply separate it with a comma. And then here's a class book that inherits from product but also implements iClonable and iDisplayable. So we just simply separate them by commas. And then if you're ever confused as to what to do, remember the IDE always gives you a quick action menu. So if you're trying to implement an interface such as iClonable that has that abstract method on it, that's going to give you a compile error because you have not implemented the method yet. So if you click the little icon over here, implement the interface, and it'll actually build out the method for you with the new non-implemented exception already on it for you. Here shows some more of that non-implemented exception. Basically, if you put it on there and forget to implement it, it'll just throw an exception. That way it's like, hey, come implement me. You forgot about me. Okay. That's about all I wanted to cover in this PowerPoint presentation as far as polymorphism and interfaces are concerned. This PowerPoint also goes through where did it go? More methods. Okay, so this PowerPoint also uses generics. So I'm not going to cover, we already used generics in this class. The next slides cover how to implement generics, maybe if you wanted to do a custom list. So remember, if you have a list of something like a list of text box or a list of products, we have these brackets here to denote that it's a list. So if you do custom list of T, that kind of says that it's telling the compiler this list can be of anything. So if you wanted to make your own list with your own indexers and methods and properties, here's how you'd do it, and here's how you'd make a generic. But I'm not going to cover too much else about writing custom classes that use generics, since C#'s pretty good at giving you everything you need. As long as you understand what a generic is, how they're used, and how to use them, that's really all I care about. Here's an iComparable that uses generics. So whenever you see these brackets, typically what that means is it's generic. So generic, it just simply means it can take any type of object, as long as it's an object. Or it could take primitive types as well. So you could have a list of integer, a list of text box, a list of product, a list of book, a list of double, list of decimal, etc., etc. So that's all I mean by generic. Okay, so let's start digging into the code here in the next video.